Hello, everyone. Welcome to the strange talk of the conference. A couple of years ago, I stumbled across this paper. And this paper has a strange name, Compound Annual Growth Rate for Software. And what it says, anybody knows what compound annual growth rate for software is? Well, basically, right, if you zoom out right here, it says compound annual growth rate is basically how something grows year over year. And they measure a couple of systems here, and they notice that somehow software systems that are somehow actively being worked on tend to evolve exponentially. So they have a growth rate that is more than zero. Year over year, those systems tend to just grow. And they say it's somewhere within the systems that they looked at, somewhere between 10 and 20%, 29%. Year over year. Now let's put it in context. 15-year growth rate, annual growth rate, 15% annual growth rate means doubling size every 5 years. Now then I said, well, is this really true? So I don't know. And then I started digging. So I went to Oloch and now Black Duck. And I looked at a couple of systems. So this is Chromium. You see it has 20 million lines of code. It doubled the size in the last 2 years. Let's take another one. IntelliJ IDEA, the open source part of it, doubled the size somewhere within 3 years. Let's take another one. Elasticsearch has 2 million lines of code now, doubled the size in the last 3 years. Let's take a look at another one. MySQL has 4 million lines of code, doubled the size in the last 4 years. And that's interesting, but let's take a look at smaller things. Maybe this is only applicable for large things. And here you have Mercurial, 300,000 lines of code, double the size in the last 4 years. What about really big things, such as like Linux kernel? They also seem to grow all the time, which is really impressive, isn't it? And this is also phenomenal because we get to touch every part of this society there are, right? There is no place right now that we don't get to touch. We, right? Those geeky people standing in front of the computer typing things there. Amazing things. But then I remembered a slightly older paper. This one is, in this case, is from 2000. And what this paper said is this. Then around year 2000, when there was this year 2K kind of problems and people started to estimate all sorts of things and scavenging through all their systems and see what do they have in there, then people started to realize that we have this huge amount of mainframe systems still in use. In this case, the estimation is that 10,000 IBM mainframe systems still in use, totaling something like 200 billion lines of code. Okay, that's an estimation. It doesn't necessarily mean unique code. It means code that runs. But still, 200 billion lines of code is a lot of code. You can look at, if you search how large software is, you will find out that those estimations are, maybe not so wrong. But still, this kind of if we take a step back between these two perspectives, on the one hand, we're creating software exponentially. On the other hand, we can't seem to be able to get rid of old systems. Now, maybe people say, maybe we don't want to get rid of old systems. Let me tell you two little stories that I heard recently. One comes from an insurance company. Their processor, the processor of the mainframe system, started to crack it a little bit. And they were looking for a replacement. The problem is nobody builds those kinds of processors anymore. So they found one in a museum. It's true. But here's another one. A railway company, like a national railway company, was having the same kind of problem not too long ago. And they were looking for a processor for their mainframe system. And they found one, but the way they were looking for through sites such as eBay, right, where there would be, they would auction against, and they found one processor somewhere in France, and then they were bidding for that one. But there was another bidder. Now, that bidder was a nuclear power plant. And it so happened it was from the same country. And the government of that country intervened. So you see, it's not that we don't want to get rid of those. It's really can't. We can't do it. So this is a bit of a kind of a big problem, isn't it? And it seems to me that we are actually behaving very much like the plastic industry from the previous century. We're exclusively focused on how we build things with no regards of how we recycle those things after we don't need them anymore. And the other thing is that when people started to name hardware and software, right? Remember that time? You don't remember. I don't remember either because it was a long time ago. But at that time, the hardware was a real building. The software was this tiny thing, this fluffy thing that you could just plug in and out as you wanted. But if you now, and the assumption there was that, if you don't need the system anymore, you're just going to, shut it down and then do something else instead. But if you're going to shut down those 10,000 mainframe systems, our economy will probably not work anymore. That's a real significant problem. And if we really are going to touch everything around our society, we might want to take a closer look at it. Now, let me tell you a little bit about me. So my name is Tudor Girba, and I do all sorts of things. On the one hand, I'm leading a project which is called Moose. That's an analysis. It's a platform for software and data analysis. I've created a method which is called humane assessment, which helps developers and teams make decisions about their software systems and the way they develop those software systems. I also happen to be in the core team of Faro, which is a new programming language. And in that core, in that environment in Faro, I'm specifically focused on an IDE where I work with the team to rethink the meaning of the IDE. You'll see a little bit about this later on. Now, it so happened, I work in industry for a long time, 7 years now, but for some reason, 2 years ago, I received a prize for my research contributions to software engineering, specifically object-oriented software engineering. And I also think that we are too focused on technical things in our world, and we should tell a bit more stories, make it more human. So anyway, I do all these things, and I recently started a company because I want to bring them into your world. But so there's a lot of stuff in there. When people ask me, what do? I tell them this. That's my job. So who finds it strange? So I teach people how not to read code, right? That's a not to read code. Okay, so who finds it strange? Okay, great. Kind of everybody. So here's my question. If I say that developers read code for 50% of their time, do you agree? Who does agree? Who does not agree? You don't know? Because it's more? Or? You're more writing code. And you're not reading code. Yeah, but I'm asking is, do you agree if you read code, if 50% of the time is kind of spent on reading and not on typing anything? So you agree with that. So we kind of agree with this. So here's the next question. When was the last time you talked about how you read code? Never. That's the right answer. And in fact, you're not alone. Nobody's talking about how we read code. Now let's put it a little bit in perspective. In business terms, it basically means that we're spending half of the budget that is given to us on something nobody talks about. This is the single largest, most expensive activity we do, and yet we never talk about it. So I said, let's talk about it for a little second. If you take away, if you think about the kinds of tools that you use, right? If you strip away every bells and whistles from your IDE, right? The largest part of the screen real estate is pretty much basically taken by a large, giant text editor, right? Now, what I've done here, I took a rather not too large system, 250,000 lines of code, and I put it all in one file. And I'm simulating what reading means. Okay? So, but I'm simulating it like a super fast. Are you familiar? Have you, is Star Trek Next Generation still fashionable these days? Yeah? Are you familiar with that one? Kind of. You remember there was this character called Data. Right? And one time, Data, he took one of those, they found a book, like a physical book, and then he opened the book and he puts his hand in it and he closes the book and so, done, right? Okay, so I'm simulating not quite that fast kind of reading, but really fast. So, in fact, if you 250,000 lines of code, if you want to read 250,000 lines of code, let's say you read really fast, one line in 2 seconds, it takes you a person month to read the whole thing. To read, not to understand. To read. Now here's the next question. Do you actually want to read code? You want to interpret the code. You want to understand the code enough to make a decision, right? But that basically means that reading is the tool you use to get to understanding. Is the primary tool to extract information out of your system, right? But it also implies that if this is not your goal, reading is not your goal, maybe there are alternatives. But you will never find them if you never talk about it. So if we put it in perspective, pretty much everything we do, right? Every time you brag about something, when you talk about development, you talk about the active part. Right? That is, I don't have it, I build it, and then I have it. Right? It's a very, very empowering thing. It's an exciting thing. It's that thing that changes the world. Right? Absolutely beautiful thing to talk about it. But half of our business is not about this. And I think we have to talk about it. And now, how do I position this problem so that we can actually start talking about it? So maybe this chart is upside down, and maybe if I present it differently, we will start talking about it. Because it's a huge monster problem that is sitting right there on everyone's desk, and nobody talks about it. So let's talk about it. And as we said, the goal, the reason we read is because we want to make a decision individually, but also as a group. So if reading is not the activity, then we first have to give that thing a name, because otherwise it's going to be unnamed. It's like Voldemort. That must not be named. And that's not a good thing, right? So I give it a name. I call it assessment. That's my definition. And my definition for assessment is the process of understanding a software system or a situation around the software system enough to make a decision about it. Okay, so what does it have to do with the other problem? Well, think about that. The problem with reading is that it has constant speed. But if reading is the primary tool we use to understand the inner parts of our system, then we have a fundamental problem. Because we're trying to match an exponential curve, an exponential growth, with a constant way of understanding what we produce. That's a big problem. So let's take a look at this again. You see, this interface has yet a different kind of a problem. When I look at this class, I'm just editing here a class, a Java class. Everybody here can read Java? Is it okay? Great. So this is a Java class. It has nothing special about it. It has a name, it has some state, it has some methods. When I'm editing this class in isolation, I feel in control. I know where it begins, I know where it ends, I know what the structure is. I'm feeling control. I look at this kind of representation, and again, I feel in control. That class is in that cage, is not going to escape, it's there. Right? It has a very, very clear structure. But let's take a look at the same class from a slightly different perspective. So what you see now here is at the center, the black thing, that's a class. And the red things, these are methods. And the blue things are attributes. And every time there is a connection between them, I draw an edge. Okay? So if a method calls another method, there will be a red edge. If a method uses an attribute, there will be a blue edge. And all of those, the methods and the attributes, they are connected to the classes they belong to. And then I lay the graph out using a force-based layout or a spring layout. Anybody knows? Everybody knows here? Who doesn't know what a spring layout is? Okay, just to explain it very quickly, imagine you have magnets of the same polarity, balls of the same polarity, but you have strings that pull them together, right? So on the one hand, they want to go away from each other. On the other hand, if there is a string, then they want to come close to one another, right? And this is how the layout works. If I look at this picture in isolation, everything is under control. But what happens if I put some context? Do you notice how those two methods, they actually want to escape together? Right? And there is one method that wants to go to the east, strangely enough, I don't know why to the east. But what happens if I put more context? Where's my shape? That thing that was nice and understandable, where is it now? What if I put more? This thing is fundamental in our systems. If I zoom back here, the first lesson that I draw from here is that context matters. But you're never exposed to it. Your tools do not show that context. That editor, the fundamental interface that you use, doesn't show it. Okay, let's take a step back now. Now, this is a super tiny system. Like, it has less than 100 classes. It was built over a period of 6 weeks by 4 people, 4 students actually. It's a very small Android app. And what they were given, the students were given a task to build this system, and they were tested from a functional point of view. Right? They were tested that this app will do what they said that it should do. And that was great. There's nothing extraordinary about it. They managed to do it. Everything was great. But here's the interesting thing. This second system here does pretty much exactly the same thing. Functionally, it does the same thing. But do you notice how it is structurally different? These 3 things here, too, did the same project. They built the same functionality. But they did it in radically different ways. The structure of their system was radically different. And so do these teams. And then we said, well, maybe it's just because we're just taking a sample that is too small, so we repeated this project with multiple teams. And it's amazing how they can produce radically different structures. Now, what do we learn from here? Well, 2 things. First thing is, if you're only constraining your system from a functional point of view, you have no control over your structure. It can go anywhere. It can be anywhere within that space. And the second thing is, the reason why that is so is that because software systems have an emergent structures. That is fundamental to how software works. So at every given moment, you understand how it looks, but the way that thing evolves is unpredictable. And that's why you have to learn how to steer it. You have to know how to react to it. At every given moment, you need to know what you have inside. And if you don't, you will not know what's the impact of your decisions. What do I mean by that? So let's take a step back here. If I look at these systems, essentially, if I'm just looking from the functional point of view, I can be anywhere here. Let's say I say, well, let's evolve this thing. Let's break it apart. Let's break this system apart and maybe implement this part here as a microservice. Who knows? Who heard about microservices? Excellent, great. This is a cool thing, and you should try to do it because it's a buzz and it's good. No, it's not just because of that. Microservices are really a great discussion opener. They've shown that we can approach from a business point of view, from an architectural point of view, from an organizational point of view, software development in a completely different kind of way. It's an amazing discussion opener. And I think it's absolutely fundamental to how softwares will be evolved in the future, whether microservices is the target architecture or not, that discussion is incredibly healthy. So is DevOps. So is telling stories and focusing on values with your system. All of those are important. But what I'm talking about right now here is the most fundamental thing. How do we know where you are? So let's say I focus on here. Let's say I think I'm here, and I decide I want to cut this system into two, right? It might work, if looking at that system, it might work, cutting it there. But what if I'm there? Well, the same kind of cut would have worked there too. But what if I'm here? How many of you have ever felt frustrated when working on legacy code? Yeah. That's most of your time, actually. Isn't it terrible to be frustrated for most of your time? Even if you're well paid. Can we not change that? I think we should. Because real systems look like this. And this is not about mess. Who doesn't think that this picture is beautiful? It is beautiful. But you have to look at it to see the beauty. And you need to understand how to look at it to see that beauty and tear it apart. Because this is the fundamental thing we need if we want to recycle our systems. We need to be able to tear them apart. Before we can tear them apart, we need to be able to understand what those parts are. What strings pull those parts together? So, first we should realize that this is where we spend most of our active life. We spend it inside that software system. This is not something we should not consider. We should make that place suitable for our, intellect, for our abilities, for our desires. And the second thing we should understand is that it is not necessarily the system that we should focus on, but the people. And these people, we have to say, so if we want to approach this problem, sustainability, not just building functionality, but building functionality that is easily evolvable in the future, this is a very, very large problem. We can't solve it, individually. We have to solve it as a group, as a society. Very much like we're trying to solve climate crisis. The very first thing we've done with that climate crisis problem was to actually frame the problem. It took 10 years for the problem to be completely acceptable. Actually, more than that. And then we can start doing something about it. So here's a starting point. Here's the very first principle. I think we, as the people that build these systems, we have the right to build on top of systems that are already recyclable. But we also have the responsibility of producing systems that are recyclable in their turn. Now, what do I mean by recyclable? As I said, recyclable means the very first thing in terms of software is being able to tell those parts apart, and then tear them apart if needed, or change them, or evolve them in some way. So that little thing is rephrased as we have the responsibility of building accessible systems, and we have the right of building upon accessible systems. But this will only happen if we actually start talking about it. So, what does it mean to build on top of an accessible system? Well, let's think, on a normal system. Normal system, people, when you're building your thing, they say, oh, give me that framework, and over this one, and that one, and this one, and put them together, and I'll just build here on top something. And then one day, the first week is fine, second week is fine, but sometime later, something happens. Somewhere deep in that pile of things you have built upon. What then? Who has experienced something like this? Do you even have a log statement saying, kind of indicating where the problem is? Or do you have just this random exception that just nobody knows what that is about, right? No, but are you asking the question of what's going to happen 2 years down the road before you're embarking, choosing those parts? If you're not asking that question, if the accessibility of the system is not part of your choice, your design choice, your technology choice, then that property will not be guaranteed. You have to start from there. For example, think of security. If you build on top of things that are, not necessarily secure, how are you going to build a system that is secure? It's going to be harder. Perhaps not impossible, but way harder and less predictable. But the other thing to understand is that when a problem like this happens, you cannot understand the problem alone. Because software has zero shape, has no shape. We just give it a random shape. It so happens that you type your code in there, but that's not necessarily its shape. I showed you a different shape. That was beautiful. So software doesn't have a shape. In order to interact with that software, we need those tools. Those things that are in the background. And the choice of those tools should be probably significant. So let's take a look at that problem for a second. In the previous century, how many of you had heard of Conway's law? Conway's law? Wow. So Conway's law, so basically we have a joke among speakers that you have to, if you give a talk, you have to mention Conway's law. Because Conway's law is so cornerstone for all these microservices hype that we have right now. So basically what Conway stated a long time ago, inadvertently, he didn't know that he will spawn the whole microservice revolution. But what he was saying was he noticed that organizations, the shape of the communication paths throughout the organizations tend to mirror the structure of the design that organization produces. Which is fascinating because it means that it's not enough to look at the system, you have to look at the whole, both the organization and the system, if you want to understand and steer that problem, which is absolutely fascinating. But about the same time, there was another person, another guy, who was called Marshall McLuhan, and he was a philosopher, and he was observing a strange phenomenon. The effect on the American culture, the effect of the newly introduced tools onto the American culture. What tools were there? The media tools, TV and radio. And what he noticed is there was a big change. Even if the tools were introduced in a very short amount of time, there was a huge change onto the American culture. And then he coined this law, which said, we shape our tools, and thereafter, our tools shape us. Which, if it's true, it should follow that we should be incredibly picky with the tools that we expose ourselves to. That choice, the choice of the tools, must be incredibly explicit. It can't be something that just happens by default because somebody else tells you to do it. It's an important choice. So, maybe it is too abstract. So let's make it a little bit more concrete. How many of you have seen slides like that? Now, we're not talking about, is this good or bad? Because we know that in, many situations, this is not the most appropriate kinds of slides. But isn't it amazing how that behavior correlates with this default structure? Isn't it amazing? That default tool correlates so amazingly strong with the behavior that people have on using that tool. Now, let's take a look at a different point of view. What's the first thing you do? If I say if you give a developer a million rows in a database and you say, well, there's a problem there, what's the first thing the developer does to go and understand that problem? Well, the first thing will be to write select this from that, right? Look at the result, maybe refine the query, look at the result again, go to that one, right? And then you say, oh, now I understand enough, I'm going to make a decision. But what's the first thing, if you give the same developer 1 million lines of code and say, well, do you have a problem there? What's the first thing the developer does? Well, start scrolling. Fundamentally, those problems are exactly the same. The behavior is radically different. Now let's take a close look at the interface. How is an SQL tool, for example, looking like? You have something like that, and a query on the top, data at the bottom. How is your typical IDE looking like? Do you notice the difference? That missing query box dictates the way you think about the problem. That's how strong this law actually is. And that's why we have to step back, way back, and think about the kinds of tools that we expose ourselves to. Now, what do I mean by that? Well, I mean this. This is a tool that you expose yourself to. How many of you are using Eclipse or something similar? Right? So what I'm having here is a very simple thing. I have a debugger that is open on a map, a dictionary. Now, what do I see here? I see an inspector, right, on that map. It's a very simple map. I just have a number and just 3 things in there, right? 3 keys and values, and I'm displaying the results of it. But is this really, what is an inspector for? If I ask you to define what an inspector is, what would you say it is? What is an object inspector? It helps you to see the inner part, the structure of the object, right? But what if, is this really the intention, to see the inner part of the object? Or is it your intention to understand the object enough to use something? Because let's think about that. Here, what I see here is I see a tree, right? Which indeed is a very accurate representation of the inner part. But let's think, if you would have to describe a dictionary or a map to, a colleague, and you take a piece of paper, what would you draw? A tree? Sorry? Yeah, you would say a table, right, with 2 columns, right? That's a much more suitable representation, isn't it? But you see a tree over here. You see, the tree, indeed, it does show you the internal, but it doesn't necessarily help you understand. In fact, who's interested in that tree representation of a dictionary? Well, the person that implements a dictionary class, maybe the compiler person, and perhaps the virtual machine developer. The rest of the 99 of the population is not interested in the tree, it's interested in the table. Yet the tool thinks it's not an interesting point of view to show you. And I think that's a fundamental property of that tool. So let's turn this a little bit around and see how could this look different. So I'll show you now a different kind of an inspector. So in this case, we have Faro. This is this programming language that I mentioned before. Oh. So here I have the dictionary that I had before. So basically here's number, and this is 42 string, and this is the string 42 and the date, which is the date today. And if I'm executing this one, then indeed I get here the tree. That's the tree representation with 3 values. But I also get a table, right? Because, well, there is no one way in which I want to understand an object. There is multiple ways. So if I want to, for example, click on the string, then the first thing, maybe I want to look at it as a collection, or maybe I want to look at it as a string with note quotes, or maybe I want to look, if I look at the number, maybe I want to saw its raw implementation, or maybe I want to see how it is represented in decimal and hex. What about the date? Well, for example, I want to see the details, year, month, name, and so on, but maybe I want to see a calendar. Because why not? Isn't it a better way to understand what a date object is? But let's take it a little step further. and say, well, how about a file reference? Let's say I'm inspecting a file object. If I'm inspecting, in this case, I'm inspecting the current directory. If I'm doing that, I can see things like this. Or that's a folder, right? And if it's a folder, I can navigate through it. And I can go in there. Or here's a text file. Well, if it's a text file, I can see a preview. Here's another folder. It has a PNG in there. OK. Here's another folder. And that folder has a Smalltalk script inside. Or yet another folder over here. Oh, look, that's an XML file. Wow, OK, that's an XML. What does it have? Oh, look, it's a catalog of books. Oh, I'm interested in all the authors. So how would I do it now? Well, one possibility would be to scroll through this file, but scrolling is something I don't want to do. So rather, because I'm a programmer, I want to say, well, why am I not looking at this one as an XML document? So I'm going to parse this one, and I will get an XML document back, and that's going to be a tree, because that's how you represent an XML document. And now, given that I'm just looking for the authors, maybe I will just quickly write an XPath over here, and I'll just explore that one. And that's going to be a collection. And now I will start reading. And if I step back here, that's how my process looks like. And this process is handled in the most basic tool I have available, the object inspector, that poor tool that people just use when, in emergency cases. And similarly, all sorts of other things get open up when you do things like this. For example, here I have a little project for a book about Pharaoh. And let's say if I want to find out what kind of files I have there, I have a picture here. Now I'm splitting those files by the representations I have. So here's all the PNGs, for example. If I click on those, then I'll get a preview of only the PNGs. Or let's say I want to understand how the structure of the folders is being there. And maybe I now want to understand, so if again, every one of those is a file. And if I want to now understand how large those systems are, maybe I do it like this, right? And that's how I consume my code or my objects. Now that is a radically different departure from that tool. You notice how the property of the tool that I'm using, that I'm exposing myself to, opens up a complete different pattern of thinking. By the way, you remember what I in IDE stands for? It stands for integrated. How are you navigating your file system? How are you taking a look at your XML files? How are you querying your database and expanding those things? Are you doing it all in one tool? How are you building your charts? Are you building it all in one tool? Perhaps that's not so integrated. I think we can go way better than that. So we have introduced this concept, and then we allowed people to start building those little pieces. Every tab that you see there actually costs about less than 10 lines of code. Every tab. And we have hundreds of those. And just to show you what it means, this is this whole space of core of Pharaoh. And then we show where did people felt the need to create those kinds of extensions, to show different points of views, and that was the impact of it. Just because we put a different property of the tool available, people started using it. And that's an amazing difference in the way we approach understanding the assessment part of the problems. Now let me just quickly go through a problem. One of the problems we had something like this. We had some widgets, and then we had a theme. The way the widgets were rendering, they were delegating it to the theme, and the theme were doing the rendering. The problem was that we had many widgets, and the theme became more than 3,000 lines of code. 1,000 methods. The question was, how do we split this method apart? And if I took a look at all the theme and all the code that is using the theme, it was about 15,000 lines of code, right? Tiny problem, tiny part of the system, that large. So how do I approach this problem? Well, let's see. So I'm going to display here all the methods of this class, of the theme class. And I will want to look first inside. Is it cohesive? Do this method call each other? And then I realize that they don't really call that well together. I don't see clusters of things that I can naturally break apart. So how else can I reason about this problem? Well, what if instead of looking at directly the methods, I will look at the things that are using these methods? These are the red things, right? These widget classes that are using those methods. So what then? Well, what happens then, you start to see those kinds of clusters. What happens if I add more and more and more and more? You notice how many of these things, they cluster naturally around one of these users, right? And that's a different way of reasoning about this. And now, did you follow me? Who did not? Now, isn't it amazing how I could explain you a problem that touched 15,000 lines of code in a couple of minutes about a code base that you have never seen before? That's how taking systems apart can look like. And the cost of building that tool was this code. Notice the missing scroll bar. This is the whole code. That's how tools could look like. That's how tools could look like. And if you step back, this is not a tiny problem. This is a huge problem, the one that I call software environmentalism. But it starts at the very basics. Because, if you want to build a system, if you want to build a building on top of sand, you're going to have a hard time, living in that system for a long time. We have to go and understand those basics first before we start going to build the future. Thank you.